Hello, hello. I know I'm between you guys and beer, so I will try to make this relatively quick. I'm Kevin. I'm the CTO at Lightspark, and I'm absolutely thrilled to be here to talk to you today about Spark. But before we get to that, just to give you a little bit of context on who we are at Lightspark, our mission is really to facilitate money movement, to make it so that we go from these legacy rails that take 3 to 5 business days, are relatively costly, it's really hard to do cross-border, and move that to the internet age, where you should be able to move data just like you move data packets on the internet, or move money just like you move data packets on the internet. And when we founded the company, we knew that we wanted to be built on something that would be around not 1 year from now, not 5 years from now, not 10 years from now, but 100 years from now, 200 years from now. And I think all of us in this room probably share the conviction that the only thing that really meets that criteria is Bitcoin. The most open, neutral, decentralized platform to have ever existed. And because of that, we've been building on top of Lightning, kind of taking the things that we all know and love about Bitcoin and making them even better, where you can move money instantaneously. You have this great settlement network. But as anyone who's ever used Lightning knows, there are a lot of shortcomings with what Lightning can support today. One of those is self-custody Lightning at scale. If you want to onboard 1 billion users tomorrow, you're going to have a pretty horrible time doing that. It's going to take you years to actually do that, if ever. You're going to fill up block space. It's going to be incredibly costly. You're going to have money locked up in pairwise channels. Say we have 1 billion users, just for $100 of inbound liquidity for each of them, you've got $100 billion just sitting there doing nothing. It quickly becomes pretty apparent that that just isn't actually going to work. Beyond that, things just kind of get worse. You can't really do offline payments well with Lightning. Unless you're running a custodial node or a node that's always online, you're going to be able to not receive money. Let's say I go on vacation, I turn off my phone, I'm in an area where I don't have cell reception, I'm not going to be able to receive money. Further, it's actually incredibly complex to run Lightning nodes and do it well. You have to figure out who you should connect to, how much liquidity to get in these channels. How do you get enough inbound liquidity? Running these in a way that actually is efficient is incredibly complex. So as looking at all these things, you can see it's pretty obvious that self-custody at scale on Lightning is just not really viable. And next, let's go to everyone's favorite topic recently, stablecoins, which I'm sure many in this room absolutely hate. But it is clear that stablecoins have some level of product market fit. And Lightning doesn't really support them well. I know there are proposals to support them, but I think we can kind of talk through in just a moment why I'm not sure that those are actually the way forward. But there is some clear product market fit. And there are many countries where people want to hold a stable asset, where it can be a hedge against inflation, where it can be an easy way to get what's equivalent to a US dollar denominated bank account, where you can actually hold this money that you know isn't going to have the huge inflationary risks. But if we look at it today, there are dozens, if not 100 chains that support stablecoins. You look at this totally not fake email from my friend Stella, who actually happens to be a dog at the office. So she's pretty advanced. She types a lot of emails to me. She says, "Kevin, why are there so many chains?" I don't know, Stella. I don't know. But there don't really need to be. If you look at something like email, there aren't 50, 100 different email protocols. There's one language that all email clients speak. Imagine if Gmail spoke a completely different language from Proton Mail or from Yahoo Mail, or anyone still uses AOL Mail. And I think that's where payments are going to converge. They'll converge upon a single network that works extremely well and serves payments use cases extremely well. And that network can be Bitcoin if we want it to be. In a world where stablecoins continue to take off, each bank's going to issue their own stablecoin. Each country is going to issue stablecoins. You're going to have potentially hundreds of stablecoins. And you need a network where they can all talk together easily. But if you look at Bitcoin layer 1, I think we can probably agree it's probably not going to be layer 1. It's not going to be a network that isn't really built for payments. It's not going to be something that takes 30 minutes for your transaction to finalize and it's relatively expensive. But what about Lightning? Our company was built on Lightning. We obviously love Lightning. But let's look at some of the options. So we can have, let's say, 100 different stablecoins. You can have all these channels between these nodes. So maybe we have 100 channels between each node. We're locking up liquidity in every single type of stablecoin. You have this huge spaghetti network. I think we can agree that's probably not going to be super viable. What about the alternative? We have a single regulated money transmitter in the middle that can convert between sats and a stablecoin, or from USDC to USDT. We basically have a single centralized database where you have this regulated money transmitter that has to KYC in each country, has to know who you are. I'm not sure that's really the future of finance that any of us are really envisioning. But at Lightspark, our mission is to make money flow, make it move more easily, whether that's Bitcoin, stables, or anything else. And that's why we're introducing Spark. Spark is built natively on top of Bitcoin and Lightning, natively compatible with Lightning, built on top of Bitcoin. So we get all the great things that we know and love about Bitcoin, the network effects of Lightning, and inherit them here. And it was purpose-built for payments, taking all the things that we need for payments and building that into what we're doing at Spark. So we knew that we had some real non-negotiables when we were building Spark. It needed to be a network that was instant. You receive your money right away, no 10-minute block times or anything like that. It needed to have offline receive, where if I, again, turn my phone off, I should still be able to receive payments. It needs to be incredibly cheap. We aren't trying to replicate the existing system where there are expensive intermediaries. We're trying to build a network where it's as close to free as possible. And it needed to scale incredibly well, something that could support billions of users overnight. Next, we knew it needed to be built natively on top of Bitcoin and support native Bitcoin, not a wrapped version of Bitcoin or a faked version of Bitcoin, but support real, true Bitcoin. Beyond that, we knew it had to have unilateral exit, where no one should be able to centralize or censor me. Shouldn't be able to have some government influence it, where the operators go offline and I can't get my money anymore. It needs to be something where I can leave at any point. No one can take hold of my funds. And next, I know we've been talking a lot about new opcodes, but as you can see here, there are countless that have been proposed for many, many years. And we knew that when we built Spark, it needed to be built on what exists today, not based on new opcodes that might come about. I think everyone in this room can agree that who really knows when or if any of these opcodes are going to come into play. And sure, we can make Spark better if these do exist, but we need to build something that can serve people today. And that's what we built in Spark. So let's go through a little bit of the technical details of what it is. So Spark is built on state chains, which were originally proposed by Rubin, but with some superpowers that kind of remove all the key limitations of state chains. But before we get into it, let's look a little bit at some of the key terminology that will help understand a little bit of what I'm going to talk about. So first here we have Spark Entity, SE, which is effectively a group of operators. So a Spark operator is a single operator within a network. Their role is to sign things and forget keys. A group of these operators is a Spark entity. They can operate either as N of N or a threshold. Next, we have Spark service providers. You can think of them similar to LSPs, where they help facilitate transactions, make them more efficient, make them cheaper. They also are kind of the edge that connects Lightning to the Spark network. And then we have leaves. So these are just the virtual representations of a UTXO within Spark. So in the ARC parlance, I guess it's similar to a VTXO. So first, let's look at what state chains actually are before we get into any of the modifications that Spark made. So just at the base level, let's say Alice creates a private key. She picks a really big random number, in this case, the number 50. The state chain and the group of SOs, they also pick a huge random number. In this case, it's a 100. Now this is based on linear aggregation of keys. So each of the SOs have a different key, and their keys sum up to the value of 100. So when Alice wants to deposit into the state chain, she generates a new refund transaction, which would allow her to spend from a UTXO that she's about to create and give the money back to her. Both her and the state chain entity sign off on this using the combined key of 150. Now Alice can safely deposit into this address because she has a signed refund transaction that allows her to claim the funds. The funds are now locked by this new combined key, which sums up to 150. So Alice now wants to send these funds to Bob. So Bob creates another new really big private key. His random number is the number 40. So Alice and Bob work together without revealing either of their private keys or revealing the SE's private key to tweak the SE's key to a new value that still sums up to the total amount 150 that the UTXO is encumbered by. So to do this, as you can see, the SE's key is tweaked by 10, which was the difference between Bob and Alice's key. So the SE's key is now 110. So when you add these together, obviously you still get the original 150 value. So a signature now between Bob and Alice, or between Bob and the SE, still sums up to 110 for the overall key, so they can sign something to spend from that same UTXO. Now the job of the SE is to forget the old key that they had. So each SO within the SE, their job again is to sign things and then forget old keys. So as long as one of them forgets their key, they no longer can sign anything in collaboration with Alice because they no longer have the original key that summed up to 100 on their side. So if they try to add something together with Alice, their 110 plus 50 is no longer summing to 150. So that's the basis of state chains. In a state chain, for each of these new refund transactions that you generate, you create a lower time lock. So originally we had Alice plus the SE. The refund transaction was valid after 50 blocks. When you then transfer it to Bob, you tweak the SE's key. Bob's new key would be this A2. SE's key would be SE2. They create a new refund transaction with a lower time lock and so on. Keep decrementing that time lock. Now you'll notice a few things here. One is this only allows you to transfer whole UTXOs. So if I wanted to transfer, I had a UTXO of 1 BTC, I can only transfer that whole 1 BTC to someone else. Beyond that, I'm really limited in the time that this can exist. So these are effectively absolute time locks because they're relative to the deposit transaction. So after, in this case, 30 blocks have elapsed, transaction 3 needs to be published on chain. So you have a pretty limited window when you can actually transfer this to other people. So first, let's take a step to kind of alleviate some of that. We'll just insert a transaction between the deposit transaction and the leaves that we're creating, which means that the only case the time bomb actually occurs is if this transaction 1, the intermediate transaction, is published. Beyond that, we can keep creating these leaves with decrementing time locks, and you no longer have an absolute time bomb. From there, let's try to solve the issue of being able to only transfer whole UTXOs. So to do this, we actually split keys and break them into a tree-like structure where you can structure the leaves of any amount that you want to. And when doing this, we actually split the amount. So if our whole value here at the output of transaction 1, or the input of transaction 1 was 150. The keys encumbering transaction 2 might be 80. The keys encumbering transaction 3 might be 70, such that they still sum up to 150. You continue splitting these keys in a way that the summation of all the leaves actually sums up to the original value of the input. And the reason you do that is so that you can actually recombine these things to more efficiently do on-chain exits. So let's take transaction 8 and 9 here. The keys that encumber these, again, were split from the parents. So they actually sum up to the same keys that encumber the input to transaction 2. So now if you own the keys for transaction 8 and transaction 9, you can actually replace transaction 2 to do a unilateral exit where you can exit now based on a new transaction at transaction 2. This allows for more efficient exits where you no longer have to have the whole tree to actually exit, but you can exit at a higher level if you own multiple leaves. So now let's look a little bit at tokens on Spark. So again, this is trying to solve some of the key issues that we feel are going to be pretty difficult to solve on other paths. And actually take tokens from something that is kind of a burdensome thing on Bitcoin right now, move them onto Spark so that you aren't filling up layer 1 with bloated things that exist today, and be able to do this in a much more efficient manner where you can now create tokens dynamically on Spark. You can transfer them any amount, and do it super efficiently, no locked liquidity amounts, no having to go through a regulated money transmitter. You can just transfer tokens like you would be able to on any other chain. But now we can kind of get rid of the 50, 100 other chains that exist because we can actually do this on top of a Bitcoin native chain and have the advantages of, again, that open, neutral, decentralized platform that exists in Bitcoin. So the way we do this, we use an open protocol called LRC20, which was published anonymously probably around a year ago. It's not all that dissimilar from Taproot assets in a lot of ways. What it does is it effectively hashes a set of token information and then tweaks the key based on that. You then have the LRC20 nodes that gossip this information among themselves. And the transactions, if they were to ever go on layer 1, look exactly like any other transaction on layer 1, where you're just going to a key. But the LRC nodes actually know that this means something different because they gossip it among themselves. So in this case, you have a transaction here that exists on Spark. You can split the amount any way you want to. And what you're effectively doing is just creating a blob of data that ends up getting gossiped among the LRC nodes. It is a top-level transaction within Spark, so you don't actually even have to have the tree structure for this type of transaction, which is one of the useful things within Spark. But it effectively just X's out the first one because you're handing away a revocation key whenever you transfer it to someone else. You then have these top-level transactions you can unilaterally exit with at any point that are just based on the LRC tweak. But if someone has replaced it, you then have the revocation key, in which case they can claim the bond that you put up, and it marks it as invalid from the LRC perspective. Okay, so how about Lightning interoperability? So Lightning interoperability on Spark works through atomic swaps of pre-images in exchange for the equivalent amount of leaves in Spark. So you effectively create an invoice where the pre-image is held by the party who wants to receive it. And when the SSP receives a Lightning payment to their node, they have to ask for the pre-image. You do an atomic swap of leaves of the equivalent amount for the pre-image, which allows you to atomically receive money on Spark. And it looks just like a normal Lightning transaction from a usability perspective. So enough of me talking about it. Let's see what kind of this looks like in practice. So here we have a Coinbase wallet where it's just going to pay a normal Lightning invoice, but it's going to pay it actually to a self-custody wallet on Spark. So you'll see here, it looks just like any other Lightning invoice. Coinbase user has no idea that this is anything on Spark. They're just paying a Lightning invoice. The user on Spark has no idea that the other side is paying natively on Lightning. They just receive money to their self-custody wallet, and they receive it over Lightning. Next, so here we have some stablecoins. See, we have $100 of stablecoins on the left in a self-custody wallet. Let's send those stables to another self-custody wallet. So let's ramp up the difficulty a little bit. Let's actually send it directly to a phone number. So in this case, we're going to send it to a phone number. They'll get an SMS, and it'll spin up a self-custody wallet right on the fly. So a user is now able to send their stablecoin or sats to anyone in the world as easy as just typing in their phone number and sending the amount to them. And they're able to now have this wallet created on the fly. You don't have to have complicated network of creating Lightning accounts and creating invoices. You're just able to get a wallet spun up immediately. Next, so at Lightspark, we've been working on an open protocol called UMA, or Universal Money Addresses. So within UMA, the goal is really to connect fiat accounts that are glued together by Bitcoin and Lightning. So in this case, I'm going to send from my self-custody account some Bitcoin, send it directly to an UMA address, which is tied to a bank account. I'm now actually paying over Lightning and having the funds received directly into my bank account. This really broadens the scope of what you're able to do with Lightning, because you're now able to directly connect Lightning to bank accounts. So what's coming next for Spark? We are planning on launching pretty soon here. We'll have a stablecoin issuance platform built on top of it so that issuers are able to easily issue their tokens, be able to do the things that they need. We've gotten a lot of feedback that stablecoin issuers have really had a headache in the past where it's a pain to integrate with other new solutions, so we're trying to make it as easy as possible. Next, we are also working on a wallet as a service solution. So we aren't launching wallets ourselves, but we are trying to make it as easy as possible for others to build on top of Spark, and to build in ways where it's more of a modern wallet experience. Instead of having to remember seed phrases, you can have a modern wallet experience where you can have recovery, you can have passkeys, you can have kind of the more modern experience. So let's look at where we are today versus where we want to go. So today, Spark is not 100% trustless. It's what we call very trust minimized. So it can be as low as 1 of n honest operators. But it's actually even better than that, because as long as 1 of n operators is honest at the time of transference, which means that they do what they say they will do in terms of forgetting the key, you are safe in perpetuity. Because if they've forgotten the key, even if they're hacked or later become malicious, there's nothing they can do. So in a lot of ways, it's actually even better than 1 of n trust. But we actually feel that there is a path toward trustlessness, and it's something that we care quite a bit about, and something that we are actively researching ways to do better. So Spark is going to be built completely open source. We want contributions from the community. We want active involvement into how can we make this better? How can we make it more useful for developers, for users? And we want to take the learnings that we have had at Lightning, where we've really tried to abstract the complexities of Lightning and make it incredibly easy to use and build on top of. Take those same learnings here with Spark. Make it where you just import an SDK, a few lines of code. You can vibe code a wallet in 15 minutes and have it working immediately, have something that you can build on top of and have developers use really easily. And now opening up new use cases that weren't super easy to do on top of Bitcoin and Lightning before, where you can be a game developer, spin up 1 million wallets overnight, send rewards and sats to users, be able to do things where you're streaming money to anyone overnight. So Spark enables these new self-custody use cases, enables stablecoins on Spark, and is natively interoperable with Lightning and UMA. We are soon introducing, well, we actually have introduced Spark Alpha, but we're soon introducing the beta version. You can get more information on spark.info. A lot of technical deep dives there, Happy to chat with people afterwards if they want more information as well. But the goal is really to build this with the community and try to make it into something that will hopefully solve real use cases for people. So these are just some of the things that we're trying to solve with Spark. I think we are on a path towards being able to really help make Bitcoin more useful for transactional purposes and be able to kind of take some of the things off of layer one that I'm sure many of you don't necessarily want on layer one in terms of stables and assets. So feel free to reach out to me afterwards or visit spark.info for more info as well. Always happy to chat. And any questions? Okay, the question was, what's the timeline for wallet as a service stuff? Very soon. So we aren't publicly announcing the timelines for any of this yet, but I think the plan is for it to be very soon.
Hey, that's great. This looks awesome. There's a lot of parallels between this tree structure and kind of the ARC tree structure. Did you say that with this extra kind of setup transaction, delaying the start of the timeouts, does that make these immortal, or is there still kind of a limit on how long these trees can live? And how do you do the rollovers if these trees are not immortal?
So the trees can live forever. The leaves themselves are the ones that have the time locks on them. So if you look at the tree structure, like all the branches no longer have any time locks at all. The leaves themselves have time locks, but you can extend them indefinitely if you want to, at the cost of basically an additional on-chain transaction in the unilateral exit case. So like, let's say my first time lock is 2,000. I could actually branch off of that immediately and go down and branch down to the next one, go down. You can keep branching effectively indefinitely. So there's no reason why it has to ever go on chain. If a user wants to go on chain, they will probably typically use an SSP because it's a cheaper approach. You don't have to worry about publishing the whole tree. You can just do a swap between layer one and the leaf node between an SSP and the user, and then you get your funds directly on layer one immediately, and it's going to be cheaper and more effective. But if the state chain entity went away, or there are no SSPs, or you just don't trust anyone, or they're trying to censor you can always unilaterally exit as well.
Cool. And what made you build this versus ARC? Like, what was the benefit for, and specifically, I mean, I see some of the differences, but what was your most central reason there?
So I think there's a lot. I think ARC is great. I don't have any problems with ARC. I think it's a really cool technology. I think we had different trade-offs that we felt were important than maybe what ARC felt was important. It's not to say one is better than the other. I think we really wanted to focus on UX and DevX. I think we weren't super comfortable with like the 30-day window in ARC. I think that we weren't super comfortable with some of the liquidity constraints that I know they're working on improvements on as well. But I think there were different trade-offs chosen. Nothing wrong with either approach. I'm a big fan of ARC and some of the people working on it. So different trade-offs.
Hey, Kevin, can you elaborate a little bit more on what you just said about the unilateral exit, about how a user kind of has a choice of either publishing like the whole history of transactions or swapping with an SSP?
Yeah, so there's two ways to exit. So one, the unilateral case is you have signed transactions for each branch node as well as your leaf. You can publish that chain of transactions. I think it's very similar to what ARC does in that respect, that you can publish that chain of transactions. Or you can, let's say, have a leaf for 1,000 sats. I can do an atomic swap of that for an on-chain transaction of 1,000 from the SSP. So the SSP basically takes ownership of my leaf. At the same time, I get ownership of 1,000 sats on chain. Obviously, there's probably going to be a small fee there because you're going to have one the L1 fee and then one just a small fee from the SSP, but it's going to be cheaper than if you publish the chain of transactions.
Are those 1,000 sats that the SSP is providing, is that like a different liquidity pool? So they're going to have like...
So they would have their own L1 funds. They can... I mean, it could be like a Coinbase, for example, or I could just purchase it from Coinbase on the fly when I need it as an SSP.
Gotcha. And then I guess so like in theory, I guess, if a state chain were to last for, say, an outrageous number, like 100,000 off-chain transactions, and I want to go to unilaterally exit and I don't want to use the SSB, would I have to confirm all of those past transactions to exit? Or like, would you be updating those? Is there a certain cadence for which
each
you would update
transaction
state
doesn't create a new path that you would have to put on chain.
Mhm.
So it's a time lock thing where you're basically replacing old transactions effectively.
Mhm.
So if there are 1,000 transactions, you probably still just publish basically the exact same tree path you would have originally.
Mhm.
That being said, like part of the role of the SSP is as they get these leaves to make it more efficient for future users of the leaves. So they may end up owning a huge chunk of the tree and do an exit themselves so that they can create a new tree that'll be smaller or more effective to exit from. So that's a key part of what the SSP does is they try to manage it such that it'll be efficient for everyone involved. But even if there were 1,000 transactions, it'll probably basically be the exact same as it would have originally because that's not that many transactions.
If the SSB then rolls over to a new stake chain and I have funds that's in like the previous tree, do I need any information from them once?
So your funds are still in the original tree.
Okay.
They may exit a portion of the tree.
I got you.
They can exit like a certain branch
But it would
themselves,
just be their
but your
coins.
funds are still in the remainder of the tree.
Gotcha.
And there will be presumably multiple trees within a single Spark because it doesn't really matter. You only create a tree when you actually need more liquidity on Spark.
Cool. Thank you.
This seems pretty cool. How minute ready are you?
Sorry, what was the question?
How minute ready are you? Like when minute?
How minute? Oh, mainnet ready. Oh, sorry. Very soon. We haven't announced the dates yet, but we plan to go on mainnet very soon.
Congrats. That's very difficult to
Thank you.
get. Yeah.
You've been waiting for a while, so I'll just be quick. But are you MIT licensed? Are you open source? It sounded like you kind of were, but
We're going to be open source, Apache 2.
Okay, similar.
Yeah.
Okay. And you've been audited and
we are in the process of doing security audits. So we've had initial audits on the protocol. We are having code audits done presently.
okay, and it seems like some of this could be done like without Lightning as the base. Is there a reason that you're moving forward with them? Why or why not? Or what's like essential that they're
So
doing? It's not
Lightning
obvious.
isn't the base to this. Lightning is connected to it and it's natively interoperable with Lightning, but Lightning itself isn't the basis of any of this. We feel there's a lot of value in Lightning. There's a lot of network effects on Lightning, and we wanted to be interoperable with it so that we continue to support the customers that are already on Lightning, and also be able to have anyone that can send from Lightning now is exposed to an even broader audience because they can now also send to billions of self-custody users. So it really just broadens the Lightning ecosystem and makes it so that you can do new use cases you couldn't have done previously.
So I'm a miner, well, actually a mining pool. One of the really common requests that we get from our customers is to get paid out in stablecoins. So we've kind of hesitated to pay them out in USDT or USDC on ETH or whatever their chain happens to be. And we've really kind of been waiting for like Taproot assets or something like this to come along. How do you think that would work? Do you think that would work well for paying out, say a miner, let's call it $20,000 every day? Is that something that would work here, or is that not really the use case you would be trying to?
No, we've actually been talking with quite a few mining pools that are really interested in this use case. It's effectively, initially the plan is for it to be completely free to do Spark-to-Spark transactions. So for you to be able to do that would be something instantaneous payouts where you can do free transactions to anyone in your mining pool. And it's a use case that we actively are targeting, yeah.
Can you explain how how UMA works and what the flow of funds are? Is it just like an off-ramp, or how are you connecting to fiat?
So UMA it's based on LNURL and Lightning addresses. It's kind of an extension of those. It's a human readable address, so like $Kevin at CoinsPH, where I can send from $Kevin's at CoinsPH to $Bob at Coinbase. And it effectively goes from fiat to sats, streams over sats, converted back to fiat on the other side. So it's kind of a replacement for a lot of the existing bank rails that take a long time to settle, or where there's correspondent banking where you're locking up huge amounts of liquidity at different banks. And it's a way to really glue together these disparate fiat networks. So you could have something like Pix in Brazil, which is like an instant bank account transfer, to UPI in India, which is India's version of an instant bank transfer. And it's glued together with Lightning and sets. And the reason we're doing that is kind of what we call like an infrastructure inversion, where initially, for example, like the internet, there were phone lines that were used specifically for phones. You start to put the internet on top of that. And then eventually the internet kind of eats the phone lines and the phone companies. We think it's kind of similar with fiat money here, where to support most people, you kind of have to meet them where their money is today, which is on fiat rails. You then start to bridge that together with better technologies like Bitcoin. And eventually it completely inverts and everyone is just on the new network. But you kind of have to originally meet them where they are so they start to get comfortable with it and start to show the use case and show the benefits of it.
Awesome. No further questions put together for Kevin.